Welcome to video number 3. Let's get down to the fun stuff. Let's talk about the two basic models of networking. We talked about transport protocols, and there was 2 of those, but now that we've got some kind of protocol set up, there's still 2 basic models to divide the world of network gaming. We have peer-to-peer and we have client-server. Let's dive in. The most obvious way to communicate between 2 computers is to hook them up and to communicate. So we would call that a simple peer-to-peer connection. And that just means everyone is directly communicating to everyone else. And if you have, 2 computers in the system, like I've got a diagram here, that makes perfect sense. I'll send a message to you, you'll receive it, you'll send a message back to me, and everything is happy. What happens though, as we start adding more computers into our game, is we start getting more connections because everyone has to communicate directly to everyone else. No big deal, not so bad, but as you start adding computers to the system, it starts becoming quite the spider web of connections. Keeping in mind you're sending the same piece of data to every other computer in the system, probably, or something like it. So adding more computers is geometrically increasing the amount of data that's flowing through the network. So the big advantage of peer-to-peer is that we are just sending our messages directly to every other computer in the system, and that results in the quickest possible ping time, the minimum lag time. So if you're trying to absolutely minimize your lag, that's certainly one way to do it. When we compare versus client-server architecture, we'll see that there's an extra hop in that, and that's going to create extra lag time. So that's a big benefit to peer-to-peer. Just to complicate things further, there's another way to slice this model that may not be as simple as it seems. Now, the data flow that I just showed was a peer-to-peer data flow. Every message is sent to every other computer directly in the network. But there's another way to talk about peer-to-peer versus client-server that seems like it's the same thing, but it's actually a different thing, and that is authority. What do I mean by authority? I mean that in a networked system, there will be some lag, and that means that each computer in the system may see something very slightly different. And this is if we're not talking about one of those lockstep real-time strategy games. In like your UDP system with your 3D action game, everyone's running around and shooting at each other and stuff, right? There's going to be some lag. And so that other player you see running across your screen is actually where they were some time ago, because there is no such thing as instantaneous communication. So that means if there's a difference in what we see, there could also be a difference in the decisions that are being made by the system. If you shoot at a particular spot that looks like where that enemy is on your screen, what if on their screen they appear in a different location? So we have this difference of opinion about where each player actually is, and that's caused by the network lag. So what do we do in that situation? And that's where the question of authority comes in. So in a peer-to-peer authority model, that would mean that each client makes their own decisions about what's happening. So let's give an example of a peer-to-peer authority model. For example, maybe we would say each client owns its own player. So as far as where am I at any given moment, I get to decide that. So the controller inputs are read on my machine. That drives my player forward. I have authority over whether I can walk through walls or open doors. So when I run forward and I bump into a wall, it is on my system that that collision calculation takes place and prevents me from walking through the wall. And then I just transmit to everyone else where my player is. So in that case, each individual client, which is one computer in the network, decides where their own avatar is and updates all the others. So that is an example of client authority. Here's another example where we might separate the authority. Let's talk about one of these shooting games. Let's say there's a grenade. So my enemy throws a grenade and it lands next to me and it goes off. Me as the player next to the grenade, I will decide whether I am close enough to the grenade. Even though I did not create that grenade, some other player created the grenade and threw it, then I will take control of the grenade on my local client for purposes of whether it hits me or not. So that gives me local client authority on whether that damages me. In contrast, consider a sniper shot. The enemy lines me up in their crosshairs and takes the shot. Now, on their screen, they can see exactly where I'm standing and they can see exactly where their crosshair appears to be. If there's any discrepancy about where I'm actually standing, then they would see the crosshair lined up perfectly, but if I was given authority to say that that shot missed, it would be very obvious to them that something had gone wrong. So in that case, I would recommend that the authority for the sniper shot damage go to the shooter, not the victim. So the shooter gets to line up the crosshairs, and when they pull the trigger on their computer, the calculation is done to see whether that shot hits the opponent or not. And then if it does hit the opponent, that message is sent to the opponent saying, you just got hit by a sniper bullet. So that's an example of peer-to-peer authority. Now, I want to make this distinction because almost nobody ever makes this distinction. We just assume that if you're doing peer-to-peer networking, you're also doing peer-to-peer authority, but it does not have to be a one-to-one relationship between those things. So that's peer-to-peer in the two ways of looking at it. Let's contrast that with the other model, which is client-server. So in a client-server model, each of the individual computers playing the game will be called a client, and we have one central computer that everyone communicates with, and that is the server. As you can see right away, with the same number of players, we have far less connections. But that does mean that each message needs 2 network hops to reach the other players in the game. So for example, here I am here, and I press the jump button. I will send the message up to the server that I jumped, and then the server will forward that message on to the other players, and then they can see my avatar jump. But in order to get that message has to go twice out through the network. And remember, those network messages are spaghetti out through all of the different network connections. Those are not instantaneous. So that could effectively double the time it takes for my messages to get to the other players. So that's kind of the balance there as far as network between the peer-to-peer, which creates the spider web of a lot more traffic, and the client server, which reduces the spider web, reduces the traffic, but then increases the lag time. Now, like what I said with the peer-to-peer mode, there's 2 ways of looking at whether we are client-server or are we peer-to-peer. One is the data flow, which was pretty obvious. But let's not assume that just because the data flow is a client-server model, it doesn't necessarily mean that the authority model is also client-server. You could absolutely have a server that just forwards the messages on, and those messages are authoritative messages that originated from whichever client sent it. So that would be a case where you have a client-server data flow with a peer-to-peer authority. And that absolutely can happen and does happen, often by accident. Let me give you an example of League of Legends. Years ago, I used to play League of Legends, and something that happened at one point was one of the players who was something of a hacker, discovered an exploit. He discovered a security hole in the League of Legends code, which was that the player abilities were client authoritative messages that were sent. So like when you hit flash, or if you hit ignite. So flash and ignite, for example, were client authoritative commands. So all he had to do was hack his client to remove the cooldowns from those messages, and that allowed him to send them as often as he wanted. And so he could just insta-flash all over the map and just zoom around the map by just holding down the flash key. And because those were client authoritative, nothing on the server blocked it. And so he was able to cheat. And that's one of the things I want to highlight here. Server authority is very useful to prevent cheating. Cheating can be a bad thing. How do you patch it? Well, you change it to a client-server authority model. In a client-server authority model, what happens is that commands come from the client to the server, and then the server has the authority to decide whether that command is valid or not. And whatever action is going to take place as a result of the command is then sent out to the other players in the system. In the extreme case, in the simple case, every command works that way, even your own. So when you press the flash button on your local client, that sends a command, now that they fixed it, that sends a command to the server that says, hey server, I want to flash. The server will validate that your cooldown is ready and that the position you want to flash to is a valid position, and then it will send back to you, this player, yourself, flashes to this position as a separate command. So without the server in the loop, you're not able to move forward. In the simple case, the server actually runs the simulation and the clients don't even move. So like, position equals position plus velocity times delta time, that's how you move. You wouldn't do that. In the simple case, you wouldn't do that on the client in a client-server model. Instead, you would simply say, my joystick was pushed this far, or I want to move at this speed. You'd send that to the server. The server would update your position with delta time, and then simply send back to you what your new position is. And at the same time, the server will send that same position to all the other players in the simulation. And that means that there's one computer in this network that has the complete authority for everything. That's one computer that is not lagging. Right? Everybody else is lagging, not the server. The server is officially the real world what's what. Okay, that does cause a bit of a problem though, which is when I push the button, I want to see it react right away, but it's not going to. When I push the button, it's going to tell the server, send a message up, and I have to wait until the server processes the message and then sends back to me what to do, and then my system has to process that message before I can see anything taking place. It's going to create a lag right on my own button presses that is going to feel kind of unresponsive. So what can you do about that? That leads us into the idea, something we'll talk about a bit later, is clients can predict what is going to happen. Like if I'm not cheating and I'm not lagging too badly, this flash is going to work and it's going to put me in the location that I clicked. So what I might do is on my client, I'll go ahead and move myself visually while I'm waiting for the server to confirm that, on the assumption that the server will tell me ultimately that I'm supposed to be there. And when I get that message from the server, I'll already be in the right position. So that would be an example of prediction. And we'll talk more about prediction later. So what games use this server-client model? It's a very, very popular model. This is, I would say, the dominant model now. Most games, so first-person shooter games, 3D action games, most types of games will now go to a client-server architecture, with the major exception being those RTS games. Those RTS games, we don't have like a central authority because everyone is moving in lockstep, right? So any game that uses a lockstep model doesn't need client-server authority, but all the other types of games generally do. This brings me up to one little nuance about client-server models. There's two kinds of client-server as well. So we have peer-to-peer, and for peer-to-peer we have data flow versus authority, and then we have client-server. And for client-server we have data versus authority. And also we have two kinds of client-server. We might have a dedicated server, or we might have one of the players in the game is the server. And so we'll see both of those out there. If you're a bigger company where you can afford your own cloud-based servers or racks of dedicated machines that are sitting there to serve games, then your client base can all log into these servers, and that will be where that authority takes place. But for smaller games, such as we make ourselves here at school, we probably won't have these dedicated servers set up. Instead, we'll need to rely on one of the players in the session will be not only a client, but they'll also be the server. So that obviously gives them a bit of an advantage. But that's how we get around the need for having these dedicated servers. One of the things I mentioned about peer-to-peer is that with peer-to-peer authority, it gives the individual clients in the system the ability to cheat. Because if I hack my own personal client just a little bit, I can send a message that is a huge advantage over the system. Like, for example, I could do the headshot. I could get in and hack the code that does the headshot calculation so that I never miss. I just have to press F1, and that will automatically headshot the other player every time, no matter where I am. You just bypass all the collision code, the line of sight detection code, bypass it and just do a headshot. And this absolutely happens even with many efforts that have been made over the years to try to stop cheating. Cheating remains an issue, not as bad as it used to be. One of the biggest ways to fight cheating is to have a client-server authority model, because now the only way to effectively cheat is if you can hack the server code. Now, if one of the clients is the server, that still opens up that possibility that they could hack their version. And so that's something you should be watching out for. Okay, also don't forget there's other ways to cheat that even the clients can do. Even in a client-server authority model, there's other ways that clients can cheat by modifying their code that wouldn't involve authority. Things like fog of war. I could turn off the fog of war on my client and see every piece of information that my machine has available to it. I could see through walls. I could have it. I could add macros that auto aim for me or something like that, based on the knowledge of where the enemy is. Things like that. And so it's definitely still possible to cheat on the client side, but not perhaps as egregious as what I could do, like maybe walking through walls if I want to, or automatically shooting the enemy. All right, so that's it for client server versus peer-to-peer. Many different ways to look at it, probably some things you've really never considered before. Even those of us who've played these games and know all about who's the server and what does that mean, have you really thought about the fact that the authority can be distributed on a per command basis even? Okay, so that's that. The next video number 4 coming up, we'll talk about prediction and interpolation, how to deal with the lag that's inevitably gonna happen. See you in video 4.